Right, just getting things set up here. Always the professional, of course. But we had some things changed messing around here, so I'm trying to clean up my desktop, my OBSs and my ABSs and all of those things. Okay, right. Enough talk. Time to get designing. So I've laid out a little board here. Hey Becky, how's it going? We are doing electronics today. Very exciting, of course. But I'm trying to figure out a little bit how all the this YouTube streaming is working, because we had a few issues with YouTube streams a few times now, but it seems okay. I'm not sure if the chat is appearing on the window and things like that. That's what I'm just messing around with. So I'm just going to just basically play with those things for a sec, just to make sure they're working as expected, or at least as near to being expected as we can hope. So yes, as I say, I'm good, Becky. I am doing okay. So I'm just decided it's time to work on something. So I've created a new project called The Unnamed Thing, and I've punched in a few pieces. It's basically designed for an ESP32 module, and I've got some wiring out here because I'm reusing part of a design I had, so hopefully a lot of stuff will just hook up. But I might need to check the labels on some of these things. But I thought let's just start laying out a board, because there's a lot of things you can do with an ESP32, it seems. So we'll want to move our USB. Sometimes though, the problem is when you start laying out boards like this all in one go, you end up with quite a lot of parts that you need to figure out what they do, what's their application. So I'm just going to put them side by side a little bit so I can have a look. Definitely this IC is the USB serial connector. What else are we looking for? We've got a couple of resistors, so R12, R14 and C7. There's R12, R12, R14, yeah. We should have a C7, we do. And I'm just going to start laying those out in something that's hopefully a little bit sensible. And then we've got the V-bus. Well, that's pretty much it. So that's the USB stage here. So we're not space constrained right now because we haven't decided what this board's going to do. Great. Okay. And then as part of the whole, hey, Dutch Retro Gamer, how are you? Welcome. I haven't seen you for a while. I'm just laying out a board. So these components are quite interesting. The ones which are just above my head in the stream. I'll just show you this. The ESP32 has modes where you can flash its firmware if you hold down certain combinations of some of the GPIOs and enable lines. So you can see GPIO 0 and this enable pin, which is EN. I don't know which one. Where is GPIO 0 on this? Here we go, IO 0. Depending on how they're controlled, it'll put it into those modes. So what we have here, which is quite snazzy, is the buttons that allow you to do this. So that's the reset line basically, and the flash line to put it into flash mode is based on GPIO 0 when it powers up. So what you can do if you wire up from your USB to serial converter the DTR and RTS lines, because you don't normally bother with those, but if you do decide to bother with them, with just a couple of transistors, you can have that being affected from the USB port, so you can actually have everything from the computer, set it into program mode, and then just dump the code. And that is cool because, of course, on the ESP32 and ESP12 you can put the Arduino stacks and then just use them as super mega powerful Arduinos. And that's why we're just pretty much laying out a board to start that, because if we have the basic reference design and that works, we can use it for loads of projects. So all these sorts of projects currently that we use are definitely Arduinos for, but some that we use even Raspberry Pis for become easy. So you've seen projects I think that Chrissy was working on, which is a laser mouse board for the Atari ST. There's loads of things like that. If we could just base on this reference design, we can just cut and paste this. The code is all very readable. All work on, we can all work on that code. It's nice and simple, and then we just have loads of projects that just all stem from it. But what would be nice is to be able to just shovel all this down into the smallest size possible. Now, if we do look, okay, you're probably questioning my sanity at this point, because I can probably get a Node MCU reference drawing. Let's check that. Maybe we're beating ourselves about the head here. So Node MCU schematic Eagle. It probably already exists. And in fact, there you go on GitHub. We may well already have one. I'm just having a look. So they've got an Altium. They've got the Eagle library. Well, let's see what they're talking about. And that's their version. Look, that's basically got the voltage regulator. Ooh. The serial converter, the flash and reset pins. Basically what we've got here, plus all of those pinouts. So I guess there's no point starting with their one unless we just wanted to emulate their one totally. And if you're going to do that, you might as well just buy one. So this is the power supply area as well. So what we'll do is let's set ourselves some constraints by taking this whole thing and shoving it right down to the edge of a board. So we say we're going to make a little teeny PCB and then see how small we can do it. It's funny though when you see things like this capacitor. It's a little 100 microfarad capacitor, but it looks absolutely whopping on here. I'm sure I could find a smaller one. Now, owing to the speeds and distances of everything involved here, it's probably not too critical, the placement of a lot of these. So we could just get away with shoving a lot of these around. I mean, just optimizing it, turning them and things just to make routing slightly easier, I think should be all we need to do. Get rid of that capacitor. That one's going to go here. This capacitor could easily fit here. Depends if we want the USB in the middle or on an edge. I think we always like things in the middle, don't we? We like things symmetrical. So we're going to put our reset button here, our flash button there. So how are we all doing in the chat anyway? Has anybody succumbed yet to any coronary viruses, or are we all still managing to be healthy? I didn't know if we want to have some sort of pox party where we all just cough it all up together and hope if we make it through alive, then that would be good. Make a chip. You're still healthy, Dutch Retro Gamer. Well, I've been out. I was taken out by a virus. Pretty sure it's not a coronavirus though. For the last couple of days, but I'm pretty good now. I'm feeling all right. So I kind of feel if it's a normal night tonight, everything will be good. Don't know if you ever get that when you have those weird fever dreams That was last night, those weird fever dreams. And some of them you're really relieved when you wake up because you're like, oh my gosh, that was particularly weird. And they're normally about events that you would rather forget in your life. So waking up and then realizing it was a fever dream is always a good thing. Oh, a spring sniffle, Floating Fat Man. Well, I think if anything, what I've realized from managing to get a little virus, a little flu, is that despite all of these precautions, I'm saying in inverted commas, that everybody's taking, yeah, I still got something. And it's like, well, maybe those precautions are not being followed, or maybe, you know what I mean, maybe they're not. Do they make it? They obviously make a difference when you're talking about lots of people doing them. Statistically, they're definitely going to be better to do them, but I don't think you should, just because you're using a bit of hand sanitizer, you shouldn't assume you're not going to get something. Because it's like, it helps, but it's not a guarantee. There you go. That's what I want to say. There's no guarantees, boy. This is a tricky one. This is the enable. The enable pull-up. Just shove it anywhere. Shove it anywhere. Mark fixes stuff. Yeah, that's worrying, that is. What would they normally smell like then for you? Perhaps we could work it out through some dietology. I think there's was a branch of ancient medicine that was to do with smelling your poops, and then they could tell how you were ill from that, or you know, the state of your health from that. Poology. Ooh, look at that. Well, we've got something going. Right, let's change the size of the board if we can. Oops. Look at that. Tight. Great. So you can have a nice tiny board with Wi-Fi, but it doesn't have any I/O. So it's only a Wi-Fi board. It can only do things on Wi-Fi. So I'm going to save that. Protein. Does it smell like protein? There used to be a doctor who would smell and taste bodily excretions. I heard doctors were underpaid, but I didn't realise it got that bad that they would try to do things to avoid having to buy lunch. Right. So I'm just going to move our board now so its full extents are back on where we want it. I've got to really sort out my snap grid on this. And it's in American money. We need to change that to Imperial. So our board is 47 millimeters long by 22 millimeters tall. So it's still pretty small. Unless, of course, we want to just mount a bunch of stuff on the. I'm going to load up some design rules, if I can find them. Well, we'll just load up some default ones then. Fine. And then we're going to just run a auto root. Normally this kills my machine, so let's hope the stream doesn't die as soon as it starts. So you think he might be dead because it was a few hundred years ago? Mark, give me some inspiration though. What can we make? But it is a bit boring. It's basically an Atari ST floppy to external floppy to Gotek adapter. That's one thing I do actually need to make. Right. So now we've got this. Let's just check real quick. I just want to see what's on AirWire. It's saying there's something it couldn't hook up here. These V-buses. I wonder why it couldn't. Oh, it can't do it because we've got the rule for the voltage buses are very fat, that's all. There you go. I did it. Done. That's a big old trace, to be honest with you. Interestingly enough, you can see the voltage coming in on V-bus is that nice big fat trace. But when it comes to powering up our module here from the 3v3, the 3v3 isn't very fat at all. Makes me worried really, because I said I've got another board that's being made right now based on some of that schematic as a reference design, and maybe I've got the wrong netlist set on it. That's not good. So what else do we need on this thing? So as it stands, you've got this thing. It can connect to the Wi-Fi. It'll act as an access point, and then when you hook to it, it'll hook onto your Wi-Fi, and you can use it to send data to the interwebs. And I might have an example of that happening somewhere. Oh no, we need a Z80 on here. I'll see if I can show you something real quick. Here you go. So this is a environmental sensor thing I've built over there, which I can't show you because it's plugged in and running. But for example, you could see this data even yourself. In fact, have a go, see if it works. That is, there's two things I got working this evening. One was the sending of environmental data to ThingSpeak, which is what you're seeing now, where you can create these dashboards of data that just get collected. I also connected a device to If This Then That, so that when it was activating, it's a microwave sensor, so when it's activating, it actually sends an email via if this then that. But this thing's interesting, isn't it? So this is temperature, light, humidity, atmosphere. So you can do all sorts of things if you really want to. So yeah, that's what I want to say is though that with this as is, you can do most of that. Obviously, you have to hook up some sensors to it. Now you could also put a relay. I've got another board. I'll show you. Bring it. If you're in my Discord, you'll have already seen these. But this thing, have a look there. I'll hold it up. That is several things. So here you have a Node MCU board, which is very similar to what you see on the screen. Here you have a Doppler radar, a microwave sensor basically, and underneath all of that is a 4-channel. See you, Dutch Retro Gamer. Good night. Is a 4-channel relay, and when you load this thing up, if I plug this in to the internet, you can see I've actually put it in a nice box. I've actually hooked it up properly with power and some relay I/O, because I had the intention of using this to switch an electric gate. So this will add Wi-Fi capability to electric gate as it is in a little 3D printed box. But that gives you a really nice web UI. I've got a very nice web UI for that. You can very quickly alter for any application you want. So all of these things you see are very useful. But you've got a compromise. Either it's useful because it's flexible, which those Node MCU boards are, because you can make it into anything, or it has to be useful because it does one thing really well. So that's where we are with this right now. It's like, okay, you've got this now, but do you do one thing really well? We could have a go for fun, just as, imagine you hook this up. You might want it to turn on and off your retro computer. We could easily do that. And by the way, the all those plug-in plugs you get, those are using the ESP12 modules. Those are exactly what's on here. Because actually, that's what I've neglected to tell you. The thing on the screen that we're designing is an ESP32. These are all actually ESP12. So the ESP12 is a single core, but the ESP32 is a dual core. So we've got a lot more power on our design here. Let's have a look for a relay, shall we? Now, if you're lucky, by the way, you get low voltage relays too, which will switch at 5 volts or 3 volts, but never really sure when you look in Eagle's CAD library what the part number of those ones would be. These sound cool, don't they? Photo MOS. So it's actually a relay, but it's actually a MOSFET. These are solid state. Miniature printed circuit board relays. Well, they sound good, don't they? High power, ultra miniature. So many relays. You know, it'd be cool though. I like things like watchdogs, like hardware watchdogs. So things that you hook up. For example, I don't know if you ever had. Oh, got it. All right, I got what we're doing with this. I'm settling in. We've got it. We've got it. I've got what we're designing here now. This will be a router watch, and what it will do, it will ping or otherwise, however, measure the strength of Wi-Fi or the latency or those things, because you know in your router I've got one where it goes a bit tonto and it loses signal and stuff and it just needs a reboot. This will live in between that, detect when it's going a bit rubbish and then power cycle it. So I think that's pretty cool. I think we've stumbled across a use case here. And I'm just going to use relays because they're nice and simple. And then if we use a relay and you want to do something fancy like switching mains power or do something a higher current later, you can. Oh no, I clicked on a huge Texas Instruments library. But that's fine. While that's doing that, let's see. We could just see real quick on DigiKey or Mouser. Let's go to DigiKey or Mouser, get a part number for a relay, a 5-volt relay. Right in the middle of a conference call. That would be perfect. Sorry, I didn't do it. So what do we have here as option? Coil voltage. 4.5 volts. 4.5 volts seems like a good way because you never really get the full 5, do you? Okay, so I'm going to keep this in one window so I can try typing out a few. So there's some manufacturer part numbers here. Let's see what happens if we try with a manufacturer part number. That was a TE part. This is a Phoenix contact part. This is a Panasonic part. Yeah, that's not going to work. Oh, we do get Panasonic relay. These are humongous though. And then we have all the photo MOS. I think I'm just going to choose a generic one for our circuit because at the end of the day that's something we can swap out afterwards. So yeah, look, there's some Omron. That'll switch 2 things if we want. That's a weird looking thing. Right, there you go. So we have our relay. We need a socket, don't we? I don't know why it's come up as a relay. We need a socket. I'm not quite sure what they're called yet, but you know when you have the plug that accepts the AC adapter on your router, that would be called something. Let's have a look again. It's the sort of thing that would break on your Mega Drive. I don't know what the hell they call them, the little barrel things. I kind of want to say DC socket. No. Okay. Barrel jack. A cinch. Oh, hang on. Yes. What's the difference? You see they've got these fat ones and thin ones? They're always annoying, aren't they, when you got a fat one? Just going to go with this one. And I guess we're going to need an out, but what would you have as the out? You're going to need just a terminal, I think. A screw terminal. Oh. This is slow. Anthony, yeah, you got it. Look at this. I tell you what, my PC is struggling. There's no reason in this day and age where something should slow down like that, but it's just they're just not made to use all your cores or anything. Got plenty of everything. Right. Screw clamps. Let's see what's a screw clamp. A screw clamp. That sounds good, doesn't it? A screw clamp. Give them the clamps. Oh, and they have a 3. Do we need a 3 or do we only need a 2? Right. I think we're nearly there. Can it be? We probably also want a transistor, and we'll need a diode, and I think we're ready to... There you go. I love this little guy. I love this little guy. And a diode. So much time is wasted. Imagine all these parts. If these parts didn't exist, and you had to create all your libraries, that would be a pain. In fact, hang on, we already have a diode on here. If you're really going to make this, you'll just want to use the same. See if you can spot it. Well, the only one I can see is that one, which looks expensive. So let's just put on a regular. Where are we? Let's find some here. There you go. Okay. So I'm not really convinced about this relay footprint. I hate when they do this. You see where they have this stupid split thing? I don't like it, but that's fine. So this is the power in, and the other thing is the power out. Oh, and those pins are separate as well. So the nice thing about this as well, you could actually set it up on a timer too, so that it could just reset itself once every day anyway. Okay. So the diode is to prevent the back EMF. I'm trying to find a picture for you, basically, to show you. And I kind of have one. It's in the Google image search, but there you are. You see it there? So you've got the back EMF here to absorb that when your inductive load decides to shove all of its juices in the wrong way. Okay. So this is our relay. I'm going to bring our transistor over. We could just pop that here actually. Why not? Hello Last Wave Dave, how are you? Thinking though, you're right, we've got a V-bus coming in that's going to be a good strong, we don't need this by the way, we've got a V-bus coming in that's going to be a good strong regulated 5 volts from our USB. So I think we'll have no problemo with that. So I'm going to set this up to V-bus. So on that one side of the coil we've got the full Monty V-bus there. And we're going to set our diode in there. And so we've got the base of this transistor is going to go to our microcontroller. If I select the right thing, there we go, we've got our labels. And then our emitter is going to go to ground. So I do like... So you can see these are pre-labeled up because I had them pre-labeled up for a different project, which is basically very similar to a Adafruit feather. That's the nomenclature I was doing. So I was going to make it Adafruit feather compatible. So I'm just looking now on all of these input IOs to see what we can use. I'm just going to pick one at random, really. So we have this one called 36A4, which I'm going to you know what? Yeah, I'm just going to rename that one. And we're going to call it relay. All the other ones we're not using I'm going to delete at some point. I just got to be a bit careful because they might be being used. I'm not sure in Eagle how you can tell if they're not being used at all. Actually, I think that the design rule check will tell you if you've got things that aren't hooked up. And we're going to put that at relay. Yes, and that's 10K. Sounds good enough. So that's that side. So then we have the power in. And power out. So I'm just looking here, really. I think it's generally center positive, but it probably doesn't really matter what you switch, does it? It's all DC, low voltage. I believe 2 will be the terminal that's required. So you've got 1, 2, and 3. 1 is the outer bit. I think 2 is the center pin, and is it saying 3 touches the center pin when you don't have anything plugged in? That's normally how they work to detect if something's plugged in. I think that's probably okay. And we're anyway, it's almost semi-speculative, this thing, right? Anyway, we can prototype it with an actual just Node MCU before getting the PCBs made. So I like the idea that the jack will be on the back. I mean, if you were doing this super cool, you would also have this thing capable of getting its power from on board, but to do that you would need a mains transformer and a whole bunch of other stuff on here, which is probably not beyond the hobbyist, but probably beyond the effort that they probably need to take or should take, because you've got the possibility of doing yourself a mischief. God, that's a big boy. Them diodes are big boys, they are. But not as big as that label. Let's get rid of that label. It's annoying me. Right. So you'd plug that USB into there, and you'd plug that power in there, and away it would go. Now, let's do something cleverer. Why don't we make it the other way round? Let's wire it up. So by default, your device is actually powered on. You see this? When you apply power, it'll right away go through to the output. Okay? And then our watchdog system can disconnect power whenever it wants. And you're saying, okay, well, meh, so. So one, it's kind of cool that if you unpower the board, it just says, okay, I'm not going to affect anything here. 2, it means if you plug its power, its USB, because lots of routers and things also have a USB that provide power, don't they? If you plug in its power here, the power source, into the router itself, when it pulls the power for the router's going to shut down, kill USB power to this board, so this board will go off. And then when it goes off, it can't hold that relay anymore, yeah? So the relay will reset back into this position, which will then reapply power back to the router. And we'd have to experiment to see if that's long enough, basically, for the router to do that. I mean, we might have to put a big cap in there to hold that a bit, just to keep the relay open just a fraction for a few milliseconds, or maybe a few hundred milliseconds, but that would probably work. I don't know how big a capacitor we'd need. Let's just have a quick look anyway. Oh, Last Wave Dave, we are designing a watchdog system. So it's a Wi-Fi accessible watchdog system that can monitor your health of your device. So you could use it to turn on and off any kind of low power device. You could have it on a Mega Drive, but the real idea is that it attaches to your router or any internet-y type stuff. I've got internet-y stuff that goes Tonto after a while if it's left on for too long, and I always have to reset them, and routers that I have to reset. I don't know why they need it, but they seem to. So this thing can be set to a timer mode where it'll just turn them off every night, or turn them off when you want to do an IoT, please turn off my thing. Or what I prefer is that it can actually monitor the health itself of your own network by doing pings and latency tests, like internet speed type tests and stuff, and then just decide to pull the plug itself. Hey, Craig, where have you been? Listening to some jams, that's what you've been doing. I need me some electrolytic bad boys. I need a big electrolytic bad boy here. That's starting to look about right. Go, Gadget, go. Go, Gadget, go. Do, Inspector Gadget. So there is our capacitor to ground. Oh, it's a big boy. The problem is, Dave, I had this idea for years and just thought, nah, this is a silly thing to make. You know why? Because technology is going to get better. People won't put up with this unreliable stuff, conking out every 2 minutes, phoning up PlusNet and BT to say my router's on the fritz again, and they'll say, oh, just turn it off and then on again and all of that. But now I think it is useful. There's also another application for this, depending on how we design it. Maybe if we use a slightly different... It's a bit dangerous just on this board, but what you could do, you could design this to be a mainsy here as well. Put mains type terminals so it could operate mains voltages. And then you can have this thing, I can't remember what you call it, shoot the other node in the head, Stronth, something like this. It's an actual proper design where you'd have this. Let's say you have two computers in your house or 2 servers. Each one of these would be connected to each server, so they'd have this watchdog hardware that can really pull the plug on it, but the opposite server can pull the plug on its partner. Do you see what I mean? So they're each checking each other, and they've got a gun basically pointing to each other's head, and then as soon as one of them messes up, the other one will shoot it and power cycle it. That's the main idea. So yeah, you can just have things looking after other things. But of course, yeah, this board is completely Internet of Thingable, so you can have any logic you want applied. I mean, you might have an external server somewhere or something on AWS that's pinging into your house or device and deciding when to do this. It doesn't have to be all on board. So that's the fun bit done anyway. We've sort of seen if we can get the parts, and they may or may not work at this point. We didn't really check them, but let's have a look for fun to see if the auto router can make any head or tail of this design. Ooh, it's having a go. It's using a very thin ground trace though, my word. Well, it says, gosh, it's getting at nearly 98%. Let's go for the 95%, shall we, and see where it needs. Oh, it's the worst parts. Look at this. It's the USB transmission line to this USB thing. So what I'll do, rather than mess around too much trying to lay out that trace, I would say it's definitely worth looking at these and seeing how they hook up, because we know these things are associated with those 2 transistors up there. So what we can do is shunt everything we can down and fit those switches. Down to there. Like that. And we're going to move these down. We're going to move this here. That's a much better place for it anyway. Craig, I could eat 3 donuts anytime. Do you happen to have 3 donuts? A lot of people like the Krispy Kremes, and I'm not too fussed, to be honest, of them, but I'll still have them. But I just like the regular donuts like you get in Asda in a bag. You know, like you get a bag of 5 donuts for £1. They do it for me. They do the job. Jam filled. That's it. Simple and effective. And then people always go gushing about, oh, but what about those fresh donuts you get? You know, the fresh ones from the market. And you're like, they're alright. But, yeah, I don't think they're that much better. No way. Right, let's have a look. Fried, not baked. Aren't they all fried, Kevin? Which are baked then? Which ones do you think are baked? Slightly stale donuts. They're a bit chewier, aren't they? You know what I like though? I think I like a hot cross bun. I'm not going to deny it. I will definitely eat a hot cross bun. Hey, Retro Tech Ralph, how you doing, sir? What's a shaking? What's a shaking? We're doing some shaking and a baking. We're doing some roasting and a toasting. We're doing some... Oh, I don't know. I've run out of steam on that. We need some thin wires on this one. Look at that snap grid. I hate it. Okay. Anyway, let's not get annoyed about such trivialities. We're literally designing stuff just for fun to exercise our brains here, so there's no point getting hung up over it. Now, the problem is we have to hit a V-bus from these 2 pins. That's what they need. That's what they want. Me precious. That's what me wants. So I'm going to select it so we can see potential points of access. So we've either got to access that fat old wire coming off the USB, or somehow get it over to here. So I could do that, great, but you can see here it's not going to be happy because that doesn't make sense. Oops. It's fine. Now let me hit that with the auto router just in case. I think it could fill that gap. I think it will. Boom. Boom. Shake, shake, shake the room. Tick, 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 boom. Yo, are you all ready for me yet? We need a bit of additional routerage going on. Look at this thing. It's almost like as if it's trying to collide with everything. Yeah, boy! Hey, Sam, how's it going? Look at this. That is looking like something we got cooking. So everybody in the chat, tell me, are we there yet? Is this ready to put on GitHub, or do we need to do a bit more? I think we do need to do one thing more at least. And while I'm doing that one thing, you tell me if this would satisfy. your IoT needs right now. I think we need to put a ground plane in. Grund. Donald, where's your trousers? Then we type in rat's nest. Boom, 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 boom. So much boom, it's filling the room. Okay, and it looks like we could do with a little groundy, little cheeky groundy via here somewhere. I think we could do a 0.3. I don't know. That's fine. And what we do then is we set the name of that via to ground. And then bang, it's filled in the blanks. And then we hit copy and we copy the vias. The reason we copy the vias is because we've already set the name. And because we've already set the name, when we do that, and then when we type rat's nest in, boom, it all works. And the circuit board becomes more done that way. I'm going to copy it a few places. We don't want any inadvertent antennae from forming. Look at that. I think we're almost there. I think we're near enough. Maybe a couple. Couple for fun somewhere. How about that? I think that's plenty. And there you have it, an actual thing that you could put in a box and 3D print. Although I kind of feel we could do with a bit of ground plane on this section. I don't know if we can squeeze one in. Ha! Sam, I had some chills and fevery stuff the last couple of days too, but I feel I am out of the worst of it. I don't feel too bad at all today. But I was having some feverish nightmare dreams last night. Have you had the feverish nightmare dreams yet? Check the rat's nest. Good. So what I'm going to do, now that we have an actual name for this project, because I've called it unnamed thing. Oh, close your current project. That's fancy. Right. Rename. We're going to call it Power Watchdog. And what I'm going to do is copy that name, and I'm going to rename all of those subfiles in it. Power Watchdog, Power Watchdog. Up. You piece of poo. .brd. Why would you allow people to rename the extension in your own UI? Doesn't make any sense. Right. So when we bring that up, there you go. It's all there and good to go. And then what I'm going to do, I'm going to go to GitHub. And you can see that there. This is my GitHub account, and we're going to do your repositories. Oh, you love the Amazon. Tell me one thing about Amazon, right? There's something weird. I had an issue with Amazon recently. In fact, a couple of issues. One I was sent the wrong thing, right? So the wrong item arrived, which is just annoying. That's obviously a picking error. But the other thing another thing I ordered that didn't turn up, but it said handed to resident yesterday. And I was like, well, no one's at home. They definitely, I promise you, they definitely did not hand it to a resident. And I thought, what kind of system can exist where... Sorry, just concentrating on writing Power Watchdog. What sort of a system can exist where something can be marked as handed to the resident when, you know, clearly it wasn't, and there's no evidence in the tracking history or any of that sort of stuff? I mean, it's crazy, right? Oh, so you had it handed to resident behind your neighbour's bin. No, you muppet! I think I jumped the gun then. I just didn't wait long enough. There you go. That's really complicated, Craig. But this is what I don't understand. If something is handed to resident and I complain, yeah, like it says a laptop, and I say it doesn't, and what they said on their online thing was, come back to us in 2 days and complain again. So I contacted them directly, and they basically just refunded it right away. And I was like, what does that mean then? Does that mean now somebody basically has a free thing and they've just refunded me? I mean, I don't really understand it. Untested design of a Wi-Fi IoT capable watchdog device. Oh. Can't spell today. The idea is that it would be connected to your router and it would monitor the health of your network using latency measures and reset your hardware if it falls a threshold or cannot get the internet at all. Can also operate on a timer. Good. I think that's a pretty good description. Oh, so it's easier to, yeah, they just don't bother investigating. Kevin, that's brilliant. Ka-ching. You can't get better than that. I think the best one I got was I was sent in a Screwfix order. So you know I like those DeWalt drills, electric screwdriver things, and I just use them forever. I did a DeWalt order and it actually had one of them in it. And if I recall, sorry, a Screwfix order, yeah, it was a DeWalt drill. And if I recall, I think I phoned them up to return it and they just said just keep it, which is crazy, right? They must have just like a budget that they'll lose like, you know, 20 grand of stuff a month in errors, and that's a figure they try to improve upon. It's just something weird. Right, so there you go. There's the Power Watchdog repository, and I'll paste that down here if anybody's really fascinated to bother to go and see it. I think it's an interesting project. If any of you actually do take up this project and build one, it would be amazing. You know, just please let me know about that one. I should probably add here, this is an Eagle CAD project. I think we could design quite a nice little enclosure as well. So that would work nicely as well. So there you go. And that's awesome about getting a free graphics card, a free unintended graphics card. You could have a nice dual graphics card set up. Again, my PC was a little bit glitchified earlier, but let's see if it's still running okay. Yeah, it's doing all right. It's just bonkers though, isn't it? How can a PC, how can you use up nearly 9 gigabytes of memory compared to like a decade ago or 20 years ago when you just had a few K? How are the things we've made so wasteful? So Kevin, it's a DC, it's power for sure. In its basic, this is for DC, hence a DC input barrel jack that accepts your power supply and terminals for you to connect and plug to continue on into your router. There. What do you think, Kevin? I think that's plenty of explanation, really. I would hope. You know, you never know what people are thinking. So there you go. Make it, let me know. If you make it, I'll send you a t-shirt, eh? That would be cool. And we'll design a case. Something like that. Now I need to go and have some hot sweet tea because I think I'm getting a little bit tired from being pooped. But speak to you on Discord. Take care. Enjoy Friday. And of course, have a lovely weekend if we don't chat before then. Bye-bye.